Hello, now I'm going to give you a brief overview over my new microcontroller based pulse generator. I'm using this pulse generator for my Stanley Meyer experiments and my Stanley Meyer replication project. The pulse generator is powerful, easy to set up, has a reasonable price, is versatile, has a modern microcontroller orientated circuit design, exact, expandable, and system grows with my requirements. I'm experienced in other kinds of pulse generators I used the last years. They were 555 timer based and they were not exact enough, and the parameter adjustment was so problematic that I decided to look for another solution, and I'm happy to have found a really professional laboratory solution now. Heart of the system is a microcontroller from Parallax. It's called Parallax Propeller. Parallax Propeller chip is an 8-core microcontroller solution. That means 8 independent processor cores are running in parallel, independently from each other, is at a system clock frequency of 80 MHz. That means that a lot of data can be processed without a single second. Main interface from the propeller chip is an USB interface to a personal computer, mainly used for firmware and application software download into the propeller. It's a bidirectional interface because in our case the pulse generator application itself makes use of the USB connection through a Windows client where all parameters are displayed and parameters can be adjusted. There are several other interfaces to the propeller chip. One interface is a switch interface, bidirectional. A switch interface to electronic switches, for example, usable for coil switching. And there's in the direction into the microcontroller a signal line for PLL feedback, so that a PLL lock function can be established in real-time operation. Every single channel, and this pulse generator has 3 of them, can drive up to 2 switches. One main switch for example, coil pulsing, and another time-dependent switch for EEC control. This bidirectional interface now is green. That means there's a galvanic barrier between the pulse generator chip and the switches. And of course there's also a galvanic barrier between both of the switches. Galvanic barrier means that there is no effort to use them at any potential you want. There is no electrical connection between the pulse generator or the personal computer and the application I'm working with. Every connected switch has its own power supply, and so it's really easy to implement any kind of switching configuration. You're also not limited to use this switch in the ground, in the system ground of the applications you are working on. Up to 3 of these switch channels are supported by a single pulse generator chip. For control of pulsing operation, parameter adjustment and parameter display, there is a Windows interface. Here in the Windows interface you can see the parameter input and display fields needed. Of course, frequency input, duty cycle input. You also have the choice to put in the parameters in microseconds on and microseconds off instead of frequency. There is an input field for increments. That means an increment of 1. If you're pushing on the plus, this frequency will increase to 10,001 Hertz. If you are setting an increment factor of 223, for example, every click on plus will increase the frequency to 223 Hertz more than in the input field now. Repetition rate means that this on-off pulse defined by frequency or pulse on pulse off times is repeated 3000 times in our case. The so-called pulse train. You can combine in a single channel up to 8 of these pulse trains. For example, in the second line you put in 20,000 Hertz, 30,000, 40, 50,000 Hertz, always 3000 repetitions, and then the whole cyclus of the pulse train will work through 10, 20, 30, 40, 50,000 Hertz, and after that has happened it starts from the beginning. You also have the choice, for example in the second line, to put in US of 100 microseconds, and that means the pulse train contains gating 10,000 Hertz for 3000 repetitions, and then 100 microseconds space within the gating time. You can activate PLL control independently for any frequency line. That means in a combination of several frequencies you can use the PLL only for the first frequency or for the second frequency or for all frequencies you have selected here. This kind of implementation makes no problem for the gating theme. Compared to hardware PLLs, those hardware PLLs are dependent on continuous pulsing. If pulsing stops, hardware PLLs, for example as the 4046, lose the PLL lock and must re-establish the PLL lock after gating has stopped or gating has finished. Okay, this was the description of a single channel and its functions. You see that this Windows interface supports up to 3 channels, and depending on the firmware you have bought, you have an operational chip for 1 channel, 2 channels or 3 independent pulsing channels. Okay, let's continue with the overall functionality of the pulse generator and leave this Windows interface now. Here's the chip. To let the pulse generator run the pulsing function, you of course need some kind of firmware interacting with the PC client and serving 1 to 3 channels of these switches. In case that it's no stationary application but a mobile application, like for example in a car, you can choose an LCD interface with 2 rotary knobs instead of the PC interface. this LCD interface also needs the pulse generator firmware itself. The rotary knobs are multifunctional knobs, and the LCD interface has absolutely the same functions as the Windows interface you saw a minute before. That means, of course, you have to navigate the fields, because the LCD is much smaller than a PC display. To make things easier, there's an implementation of a protocol screen to a terminal program, which shows all the fields you have seen in the Windows interface here as read-only parameters, so that the necessity to navigate through the LCD interface is limited. It's easier to use. Of course, the chip supports and is prepared for system bus components, an expansion bus, you can say. Those system components are also coupled galvanically isolated. What are these system bus components? Those are potential free sensors and actors, like pressure sensor, voltage regulation, temperature sensor, motor control system. You have the choice to use the Windows interface for control and display, or the LCD interface with screen dump support, let's call it so. And now the question is, where do you get the components from? Let's make a list. You need a controller, you need the pulse software, or let's call it the firmware. You need the LCD display, you need the rotary encoders, you need one or more switches, and you need a system control board. This system control board is not mandatory, but it makes life easier because the connections needed to give a power supply to the controller and to connect the controller with the operational amplifier for PLL amplification, for PLL system signal amplification, for the LCD display and rotary knobs and some other components. It's easier to be realized using this system control board. They call it baseboard. The controller itself can be purchased at Parallax in their shop. Price for the controller there is $49.99. The control program for the pulse generator and the firmware for the personal computer, the Windows interface, or the firmware for the LCD can be purchased from Innovationsshop, the internet address sourceforinnovations.com. They sell microcontroller based applications and user specific POM bobbins. POM means Delrin, for transformer design and transformer build. What is the price for the whole stuff? There's a special promotion for new energy developments, and this means for the Windows control program and the firmware for the PC, for one channel you only have to pay $20, and the same if you decide to get the LCD solution. The firmware costs $20. You only need one of the solutions. You have to decide, but you must decide if you want to use the Windows version with the Windows client, or if you want to use the LCD version where you need the LCD hardware and the rotary encoders. Here our list again: controller solved, pulsing software solved. LCD you can get in the internet. You have to search for Devantech LCD03. You have to watch that it's the Devantech variant, because there are other alternative LCD03 at the internet, but they are not supported by the pulse generator. The rotary encoders are from Alps. You have to search for Alps encoder. The switch or the switches galvanically decoupled you get from Innovationsshop, and also the system control board, the so-called base board, you get from them. You don't really need the baseboard. You can also set up a working pulse generator application on a simple breadboard. You can get all components I talked about at Innovationsshop, of course, and they are available there as a complete product, as a building kit, or as single components. Thank you for watching and enjoy.